Good afternoon, everyone, and thank you for joining our Cambridge Senior Science VCE Physics webinar this afternoon. My name is Emma Kaplan, and I'm the Victorian Education Sales Manager here at Cambridge University Press. Before I make a start, in the spirit of reconciliation, Cambridge University Press and Assessment acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. This webinar is being recorded and you will receive a link to the recording along with the opportunity to give your feedback on your experience this evening. You can expect to see this arrive in your inbox within a week, so please do provide your feedback for us. You can ask questions in the chat box, which we will be monitoring throughout the webinar, or if you prefer, you can wait until the end. We do have a Q&A session where Chris and Rex, our presenters, will answer your questions. I'll be detailing publication dates, sample dates, plus product pricing and purchasing options at the end of the webinar, so do stay tuned for this. Before we begin, I'd like to introduce you to our presenter, Chris Dale. Chris is Head of Physics at Brighton Grammar and is presenting on behalf of the author team that has put this presentation together. The author team includes Eddie de Jong and Dr. Sid Boydell, who have decades of experience in teaching course design and assessment of VCE physics. Also in the team are Mary McMillan and Andrew Hansen, who also have years of experience in VCE physics teaching and assessment. And also presenting today, we have Rex Parry, the senior science publisher of the series. So without further ado, I'm going to hand you over to Chris. Thank you.
Thanks, Emma. And yeah, welcome everyone. And firstly, thanks for coming. Yeah, we really appreciate your time and hopefully we can provide you something of value here. So we'll get started. So the first thing we wanted to go over was just looking at the key changes to the study design in Unit 1 and 2. Now, this was implemented this year, obviously, so we've just provided this summary slide. And so you guys will get access to these slides and we won't really go over this too much just because it's already in effect. So moving to the next one, we're going to spend most of our time on the key changes. So what's been taken out of Unit 3 and Unit 4. So here's what's been taken out. So I'll just go through it one at a time. So model the acceleration of particles in a particle accelerator, limited to linear acceleration by uniform electric field and direction change by a uniform magnetic field. They've also identified the advantages of the use of AC as a domestic power supply. They've also taken out the following from Unit 4. So explain quantitatively the Doppler effect, explain resonance as the superposition of a travelling wave and its reflection, and with reference to a forced vibration, oscillation matching the natural frequency of vibration, and analyse the formation of standing waves in strings fixed at one or both ends. Then they've also taken out all of the stuff on Snell's law and also the stuff on the electromagnetic spectrum, polarisation, and colour dispersion in prisms. One that I just want to draw your attention to, so it's the third from the bottom. The de Broglie wavelength is still in the study design. It appears as calculate the de Broglie wavelength of matter. So it's the de Broglie wavelength equals h, which is Planck's constant over momentum. So that's still in the study design, but recently VCAR released a notice just saying that there are going to be no more questions on the 2D models of the de Broglie wavelength. So you've probably seen these in a few past exams where they model the de Broglie wavelength as almost like this two-dimensional guitar string that's vibrating in a circle that has various peaks and troughs within that circular pattern. So the decision, I suspect, was made to remove that just because really it's not a great model of de Broglie's wavelength, and really if they want to introduce a model, they should probably go to the SPD orbitals, which is a much better reflection of that model and is a much better reflection of like the de Broglie wavelength. So yeah, you won't be asked about the 2D models to draw them anymore, but you will definitely be asked about the formula. Then our final ones, explain how diffraction from a single slit experiment can be used to illustrate Heisenberg's uncertainty principle. So that's been taken out. Also explain why classic laws of physics are not appropriate to model motion at very small scales. That's been taken out. And comparing the production of lasers, of lights in lasers, synchrotrons, LEDs, and also incandescent lights. So all of that's been taken out. All right, so what's been added in? So we'll go through these sort of one at a time. So the first one is investigate qualitatively. So this is a key word here, qualitatively. So students won't be asked to do any sort of mathematical calculations. The effect of current, external magnetic field, and the number of loops in a wire on the torque of a simple motor. So what I would suspect is going to come from this is your worded questions. So being worded questions, they're probably going to be the more difficult ones. They tend to be harder based on past VCE, just exams. And so you're really looking at this as two parts. So the first thing is the students need to use the formula on your screen. So it's going to be the one on the left. So they need to look at how the number of turns, the current, the length of the wire, or the strength of the magnetic field is impacting the force. And then obviously as that force changes, what's going to happen is that torque's going to change. Now, I would suspect that this torque formula, so torque equals the radius times force, probably isn't going to appear on the data sheet. So it would be worthwhile, sort of telling the students to put that on their page of notes. And because really it would be, you show that formula. For example, if the current was increased, show that the force increased. And then from their studies in year 11, you could see if the force is increased, then the torque would be increased. So I would suspect written questions around that, but obviously the formulas help with the written questions. Okay, so moving on to the next change. So some of these have been modified. So one's been taken out, but it's been put in with something similar. So here's an example of that. So what's been added in is to model the acceleration of particles in a particle accelerator, including synchrotrons, as uniform circular motion. So limited to linear acceleration by a uniform electric field and the direction change by a uniform magnetic field. So what this means is we can get changes that aren't going to apply special relativity, especially given that this is in Unit 3. You wouldn't be expected to know that. And also when things are bending in an electric field, that's general relativity. But it might add some more application questions. So for example, here we've got a mass spectrometer, and based on the mass, things are bending different amounts. So then they start to come out some questions in the VCE exams relating to applications of this. So things like mass spectrometry. All right. So another change in Unit 3 is the addition of these photovoltaic cells. So it says describe the production of electricity using photovoltaic cells and the need for an inverter to convert power from DC to AC for use in the home. So we sort of looked at this and thought about how this could be asked. Now, it's important to note here, we've just written it down. So details of electron motion in NP junctions is not required. So describing how photovoltaic panels change sunlight into electricity and the role of inverters, that's really the most important aspect of this. And there may be some applications as well, such as electronic vehicles and battery technologies that are used in these application type questions. And it could be combined with other stuff. So it could be combined with something like power transmission lines, we think, and we'll show you why on the next slide. So the photovoltaic cell, that's we've just put a diagram of what we think this is the most common use, and we think this is what VCAR will use. We would suspect they will release that at some point. Here's just one simple worked example, just showing the power. So you've got a certain voltage being produced, a certain current that's being measured, and then just doing the power output. So they're probably going to be the simpler questions. We think probably the more difficult questions are going to be something like this. So looking at series and parallel, and how these photovoltaic cells can be wired on series and parallel, and the effect that this might have on the voltage and also the current. So for example, if we were to wire, we've got 3 photovoltaic cells. They're each 400 watts. And their voltage is all the same as well. So they're each producing the same amount of voltage. But if we wire them in series, we have the same power, the same total power, but what happens is the current is 27.2. But then if we wire them in parallel, then that current goes up, and it goes up to 81.6. So we think this is a foundation. So they might ask questions like this, and this could be part of something larger, we think. So we think this is going to be added to transmission lines. So for example, there might be something like 3 in series. So a farmer might have like three solar panels, for example, on his farm, and then they might have a long cord with a certain resistance that goes up to the house. And then they could obviously ask a whole range of questions in that. So it may be just DC. They may say, why is there a need for an inverter? And then, of course, you would say the need for inverter is to convert the DC to AC. So it can then be used for a transformer to step up the voltage and reduce the power loss in these resisting wires. So yeah, there's a few ways that they could ask this question, we think. All right, so moving on, this is all the stuff in Unit 4 that's been added, so a fair bit. So these ones, I'm just drawing your attention to it. So what we have in the middle, if you look, is just an interference pattern. So central bright band, 2 dark bands, and then bright bands, then dark bands. And it's easy to miss, but you can see that the path differences, the formulas for path differences, in the previous study design for destructive interference, it was n take a half, and now it's n plus a half. So the impact that this has is that central bright band, the n number is 0, and then those adjacent dark bands, in the previous study design, you would have said it's 1, but in this study design, you say it's 0 as well, because obviously for that first destructive interference pattern from the central band, then your n has to be 0, because 0 plus a half is just going to be a half. So there's a difference of half a wavelength there. And just the second dot point down as well, they've just added in where L is much greater than D. So where the length between the light and the slit apparatus is much greater than the distance between the 2 slits, because if those distances are approaching 1, they're getting closer together, then what happens is you don't really get the same effect. That equation doesn't really work. So they've just added that in. Okay, so they've reintroduced the interpretation of the null result of the Michelson-Morley experiment as evidence to support Einstein's theory of special relativity. So this is, of course, one of the most famous failed experiments, which shows that the speed of light isn't invariant. And we think that there's actually a lot of stuff on this. So it was taken out in 2016, but you can have a look at those past papers to see where this has been used. And we think it's going to be used in a similar context. So just interpretation of the mechanism, so how the interferometer basically works and why the movement of a medium would cause it to go out of phase. And then also what it indicates or what postulate it supports. So the fact that the fact that they got a null result shows that it is evidence of Einstein's theory of special relativity, and it specifically supports the fact that the speed of light in a vacuum is constant. All right, so this one is applications of special relativity. So there's two ones that's been added. So the first one is particle accelerator lengths must be designed to take the effects of special relativity into account. So if you just look at the diagram down there, you can see that they've got drift tubes there of increasing length. And so those drift tubes need to be of increasing length because between the drift tubes, what's happening is the particles are accelerating. So they're accelerating between the drift tubes. And then within the drift tubes, they're remaining at a constant velocity. So looking at this, we think really they could ask you a question about why that happens. So talking about in the particles reference frame, the drift tubes are going to contract. And the faster those particles are going, the more length contraction is going to occur in the particles reference frame. So therefore, there's a need for them to be bigger as the particle travels faster and faster. So there could be a quantitative question on that, or there could be a qualitative question. So if you look down at worked example 9B4, length contraction of a drift tube, you can see that this one has a proton that's traveling 99.5% the speed of light, and it passes through a drift tube, and the drift tube is 8.55 centimetres long in the particle's reference frame. So you just need to see how long that is in the scientist's reference frame. So of course it's going to be larger, and it's larger by a factor of 10. So they could ask you to apply that. So the next one is time signals from GPS satellites must be corrected for the effects of special relativity due to their orbital velocity. So if you look down in the bottom left on question 2, we think it could be asked in this way. So a spacecraft passes by the Earth at a relative speed of 0.75 c. Which of the following statements is correct? So ignore the effects of gravitational time dilation. So just looking for the fact that, if we're thinking about special relativity, if we're standing on the Earth and something, spaceship, well, the GPS satellites are moving very quickly above us, then the time in the GPS satellites is going to slow down as measured by us on the Earth. And so a correction for that, so in order to correct for that, you'd have to speed up the time signals from the GPS satellites to keep them synchronized. Now, there is something to be aware of here that in actual fact, so if students go and do their own research, they'll find that the clocks, they actually have to be, instead of slowed down, they actually have to be sped up. And this is due to the effects of general relativity. So just being really careful that you're not including that general relativity in there, and you're sort of steering students away from the effects of general relativity. All right. Okay, so this one, this is applying energy mass relationships. So the conversion in the sun, also positron electron annihilation, and also to nuclear transformations in particle accelerators, while details of particular nuclear processes are not required. So you can see there on the top left-hand, there's just a diagram of nuclear fusion. And then question 8 and 9, they're two questions that we think might relate to mass conversion. So they might ask you to explain it. So explain, for example, where that lost mass goes, or why does it lose mass? And in question 9, they might ask you to do this qualitatively as well. So they might give you a mass deficit, and you might have to calculate the energy. So positron electron annihilation. So if you look on question 23, we just think that when they're just going to collide with minimal kinetic energy, and then obviously they'll annihilate each other, giving off their mass being 100% converted into energy. And then the last one, nuclear transformations. So worked example 9D6. This is the type of example that we'd expect. So when something collides, I might give you the mass before, the mass after, or I might give you the mass defect in a collision and ask you to calculate the energy given off as a result of that collision. Or it might ask you just to quantitatively say, why is there mass lost when they collide? All right. So I'll quickly run through this. Here are some just preferred terms for the study design. Some of these are new, are old. So potential difference is now the preferred term for voltage. So what this means is in the exam, they're going to ask for potential difference. So it's just a good idea to start using those terms with your students so they become familiar with it. Normal force is the preferred term. So it's possible to have a normal force equal to 0, but you shouldn't be describing things like on a roller coaster, someone being weightless or apparently weightless. And it's been picked up in previous VCE exams. Force due to gravity. So that's the preferred term rather than weight force. Just to try and break this really common misconception of the reaction force of the weight force being the normal force. So the force due to gravity, hopefully that's leading students more to the fact that the reaction force to that is going to be gravity, the force of the person on the earth. And then the last one, just the force on A by B. All right, so with significant figures, just something that there's been a bit of discussion about the inconsistency of significant figures on the current data sheet. So for example, acceleration due to gravity is given as 9.8 meters per second, and Planck's constant is given to 3 significant figures. So we hope that a new data sheet will be released where all the significant figures are 3 significant figures for just consistency. And the last one from me is just looking at the implications of changes for the external exam. So currently the internal and external assessment components are 50-50. Now, they're currently 40-60. And in the new study design, so next year, it'll go to 50-50. So there'll be a bit more weighting towards the internal components. Now, there are weighting changes to Unit 3 and 4. So Unit 3, outcomes 1, 2, and 3, they're all worth 40 marks. And then Unit 4, outcomes 1, 2, 3, they're worth 40 marks as well. So this means Unit 3 overall is worth 60%, and also Unit 4 is worth 40%. So if we look at past papers, we can see that in 2017, when the new study design was introduced, they released a sample exam and also a formula and data sheet. So we would expect them to do the same thing, where the sample exam guides the type of questions and also the formula sheet gives you a bit of information about what's required. And probably like biology, we suspect that the new exam would be out of 120 marks, not out of 130 anymore. So we would suspect that it's 30 marks multi-choice and also 100 marks short answer. And so if we look at past papers, we know that historically speaking, the Unit 4 area of study 2, so that's scientific investigation, usually gets less weighting as it's internally assessed. So yeah, what we think the breakdown will be is something similar to this. So something similar to Unit 3 area of study 1, 2, and 3. They'll all likely get 24 marks allocated to them. Unit 4 area of study 1 is probably going to be about 26, and Unit 4 area of study 2 maybe about 22. If anything, it'll be less than that. All right, I'm going to pass over to you, Rex. Yeah, thanks.
Okay, thanks very much indeed, Chris. For that, I'm going to touch on some features of the resource. One of the principal features of the whole Cambridge Science series is the way that coverage of the study design is indicated and can be assessed through learning intentions. And On this slide, you see at the beginning of every chapter, the study design key knowledge points are given, and they're broken down into learning intentions, which are worded to say that at the ends of this chapter, I will be able to do the following. So this puts a specific focus on all the key elements of each dot point, and those learning intentions. At the end of the chapter, I'll be able to do this. They can then be assessed. And at the end of the chapter, we give a checklist, and the learning intentions are repeated, but now instead of being I will be able to do, it's now I am able to. And exactly the same criteria are here as at the beginning, but we also have, against the success criteria, we've got linked questions indicated in the chapter review. So students could self-assess against these success criteria. If they can put a tick in the boxes for those questions, then they've succeeded against that criterion. Or alternatively, the teacher can do the checklist for them. They can print their own copies off from the digital resources and have that as a record of their learning in the chapter and their success against those questions. So in the interactive textbook, these boxes will be automatically ticked by the system if it's a multiple choice question and the answer is auto-marked as correct. For the short answer questions, if the student self-assesses as as having achieved a correct answer compared to the suggested response, in the system, they self-assess as having done the question satisfactorily, and they'll also get a tick in the checklist like that. Okay, I'm going to summarize very briefly the resources available in the senior physics bundles. You can buy the print bundle or digital bundle and the separate teacher's resource, and Emma will give a bit more information on that towards the end. There are two print books, Units 1 and 2 published at the end of last year, and Units 3 and 4 will be published at the end of September. Please request inspection copies if you don't already have them. There's a detailed overview at the front of each book, which is a guide to all the components and the features. Okay, I'll just say a little bit about the downloadable PDF textbook, which is provided for use on devices when you can't go online, or if you prefer the PDF reading environment. Standard tools are provided in the software for annotations and searches. I mean, in the PDF reading application that you're using. Okay, the interactive textbook is the online version of the print textbook that has been optimized for use on screen, and it's supported by digital multimedia and interactives. It's got many innovative features based on the Edging digital platform, which is used by thousands of students across the state. Questions as on this screen, can be done online with automatic marking of multiple choice questions and self-assessment of short answer questions. Student marks and working are fed through into the teacher's learning management system. And if you go to our catalogue website or our YouTube channels, you can see videos and explanations of how these interactive textbooks work. Okay, the interactive includes concept videos for many of the most important concepts. It has screen capture videos going through all of the skill boxes step by step, and for every worked example as well. So some students may prefer to view them this way, especially if it's working through a complex calculation. Many of the diagrams, you can see there at bottom right, have got animated PowerPoint presentations. Teachers can use these as demonstrations, or they can be browsed by the students working on their own. The online teaching suite contains all the assets, digital assets, and all the testing features and access to the exam generator, and it also provides the learning management system for the students' results. So there's a huge range and number of additional downloadable resources, especially worksheets, chapter tests, practicals, chapter summaries, and curated internet resources. There's copies of question sets from the textbook, which you can use as an alternative format to the textbook. And the online teaching suite also contains a test maker based on multiple choice questions. It has practice exams in PDF format, and it has practice school-assessed coursework tasks in editable Word format. The digital material will also contain 10 Unit 2 options. They're generally about a dozen pages long, and they provide 10 or 11 of the unit options with examples of questions that can be used. The online chapters also include material on scientific investigation methodology, which is standard for all the books in the series, and also guidelines for teaching and learning First Nations knowledge and science. Some of this material is still in preparation, particularly if it goes with units 3 and 4, but will be uploaded before the end of the year. Okay, material I'll just mention will also be provided on the on how to use the digital materials. Now, Now, lastly, when you adopt the Cambridge VCE Physics, you also get access to our new exam generator platform. And we're now going to watch a short video that presents this resource. And after that, we will take questions. So please run the video.
This video will step you through how to create a practice exam for your students. Click on the Tests and Exams icon. This takes you to your test bank. Click on Create. Select Exam and then choose between an online exam using only multiple choice questions that will be auto-marked, or PDF, which can also include written answer type questions. The top section allows for a custom name and description. Use the drop-down arrows to select the course material you want your questions drawn from. You can filter your selection to include only VCAR questions by level of difficulty and by question type. Once you've hit the search button, all of your search results will populate in the left-hand panel, and your draft exam will appear in the right-hand panel. To add a question to your draft, click on the plus symbol. Use the down arrow to expand and view a whole question. Use the plus at the top of the search panel to add all questions from this page to your draft. The draft exam will be divided into multiple choice and written answer sections. You can search with different criteria for more questions to add to your exam. Expand the draft exam panel with the Fit Screen button. Change to column view and drag questions to a different page. Preview a question with the eye icon and use the trash can to delete. Return to the two-panel view with the split screen button and use the preview button to view all questions with the answers. Save your exam and return to the exam bank. Select your exam and hit the print button for a downloadable PDF of your practice exam. A range of other help videos that might interest you can be found on our support pages.
Okay, thank you, Rex and Chris. That was really informative. So now it's time for our Q&A session. So I'm just going to have a look at a couple of the questions that have come in so far. So let's look at the first. I've answered the first one to James. So Joshua has asked, apologies, I've been in and out. Was it mentioned that the exam generator was novel questions or previous VCAR and related questions? If novel, are any of them included in the test generator, or are they separate sets?
Yeah, so I can answer that one.
Yep.
So they are separate sets. So the exam generator is mainly VCAR questions, so it's all the way up to 2022 at the moment, and new questions were actually written. Say, for example, the new stuff that was added in, so like photovoltaic cells, we haven't really had that before. So we don't have a bank of questions, of past VCAR questions to draw on. So new novel questions were written for that, which is separate to all the questions in the book and all the questions in the test generator. So they're completely original. And yeah, the ones that were written, that is. And then the other ones are from VCAR.
Excellent. Another one from Joshua. When you say the investigation methodology, and guidelines for First Nations science perspectives is common to the series, is it different from the Unit 1 and 2 content? Additionally, is it set out similarly so sections for Year 11 and 12 are in the same order?
Okay, I think that might be one for me to answer. The material for First Nations knowledge and culture in physics. That's a standalone thing which is being prepared for science in general, with some examples from each of the main science. And that's more about how to approach the teaching and learning of First Nations knowledge, concentrating on respect and ethical aspects, and also putting together some links to web material that can be used. The science investigation methodologies is a separate thing, which will be the same that you get in both units 1 and 2 and in units 3 and 4. So you can decide, so teachers can decide when they use it and when they build some of that into their program, which could be in year 11 or year 12.
Thank you. Next question, any editable output format for the exam generator or just PDF?
I'm
not
actually sure about that one. Rex, do you know if that would be PDF. If you want editable material, then the chapter tests and there will be a practice exam. Those will be in an editable format. So you can use Word to create your own versions and also integrate it with your own questions.
And one more question from Stephen. When is full pricing released? Stephen, I'm going to talk about that when we've finished with this Q&A, so I'll answer that in a moment. Now, that's all the questions we have coming in through here, but Chris, I feel like you may have some more that came in earlier.
Yeah, we had one come in earlier, just about the photovoltaic cells. So the dot point starts with describe. And so there was just a question about the word describe leaves not a lot of scope for the questions. And probably throughout this, you saw that I went into a fair bit of detail in the photovoltaic cells. Now, the reason for that was just looking back at past papers, they've done similar stuff like this before. So, for example, if you look at the motion unit, they don't actually have the SUVAT formulas. So they are in the data sheet, but they're not specifically written down in the study design. They weren't last year and they're not this year, but obviously it's expected that students know them. So, and I went back and I looked at a question from 2013. So there's one question from 2013 where they actually use a bank of solar cells. I think it's on about page 31 of the 2013 exam, if you want to look it up. And they use a bank of solar cells that provides a DC current that goes to a household. And from that household, the wires between the solar bank and also the household, they provide a resistance. So it's essentially a power transmission question with DC current. So at the time, that would have been a really, you would have thought that would have been a question that, it's a bit different from the usual one. So it's not AC, doesn't have a transformer in it. And I think if we draw from that, the fact that they've actually had a bank of solar power of panels integrated with a transformer previously, I think it's reasonable to assume that they're going to do that. Now, there is scope, and I would suspect, like I said, they'll release a sample exam. If it's released in a sample exam, then, it gives the teachers a better idea of what sort of thing to expect, and also it gives the examiners sort of more scope to assess that dot point. So I would think that we should be looking really, really closely at that sample exam, because that will help really tell us a lot about some of those dot points and how those dot points are being interpreted by the examining panel.
Okay. Now, we haven't had any other questions come through, so that was all the questions that you had previously, Chris?
It was.
Yep. That's okay. Well, we might go on to my slides then. Thanks, everyone, for that. So at the moment, you can preview the complete Units 3 and 4 textbook. It's available online. You can copy and paste the address that you see here into your web browser to view the samples. You'll also be able to see more details on the textbooks as well. As Rex mentioned, the Unit 3-4 textbook is available at the end of September, and Units 1 and 2, of course, is available now. So I would encourage you to get in touch with your Cambridge rep. They'd be more than happy to come out and show you through the resources that we have, and also show you the platform that these resources are supported by. Rex has touched on what's available, but there's even more to see, and we'd be more than happy to arrange trials for you as well. So I'm going to show you your rep's details in a moment if you don't know them, but yeah, I would encourage you to get in touch with your rep and get some trials happening at your school, so then you can have a look for yourself at these fantastic resources. Next slide, Nicholas. Okay, perfect. So here's the pricing. So print and digital. The print book includes the digital, which gives you access to the interactive textbook. The code in the book will give you that access. There's the option to purchase the digital book only. And then, of course, there's the online teaching suite, which includes loads of resources. If your school book lists our series, then all of this is provided to you as complimentary resources for your school. So you just need to get in touch with your rep and let them know if you do book list. We'll arrange that for you, and we'll arrange access for your staff as well. You just need to let us know. So I think the last slide I've got here is your rep's details. So if you're in the Bayside Mornington Peninsula area, that's me. So get in touch with me and I'd be more than happy to come out and show you the resources. Carolyn looks after the North and Northern Victoria as well. We have Kim, who looks after the East and Southeast of Melbourne and Victoria, and then Marcus that looks after the West. So yeah, please do get in touch. We haven't had any more questions come through, so we might finish off our the evening. And if you do have any more questions after the session, please do feel free to email us. So that does bring us to the end. And on behalf of Cambridge University Press, please join me in thanking Chris and Rex for their contributions, and wishing you all a very good evening. Thank you.